Hi everyone, this is Mrs. Torigno and this is the Unit 11 test review for Geometry A. This was our unit on trigonometry. I'm going to do my best to walk you through these problems as best I can here, but as always, if you do have questions, please feel free to ask in class. So in number 1, the first thing I notice is that it's talking about an isosceles right triangle, and that should be sort of a trigger word for you to think of special right triangles. Let's take a look at those diagrams. Up at the top here, I've shown you the 45, 45, 90, which is this triangle here. It's the isosceles right, and then the 30, 60, 90. And remember, these are the patterns for the side lengths in those special right triangles. So these are sort of special cases of right triangles. So now I'm going to go ahead and set up the picture that number 1 is talking about specifically. It's an isosceles right, so it's going to be similar to this one. Okay. And it does tell me that angle C is my 90. So this is C. And because it's isosceles, it doesn't really matter which is A and which is B. And it tells me that this length, the hypotenuse, is 7. So you should see that this 7 is in the same position as the x square root of 2 in that diagram. So the 7 matches up with x square root of 2. That means when I go to solve my equation, I'm going to set it up as 7 equals x square root of 2, and what I want to know is what x is, because I want to know what these other sides are. So let's solve. I would divide by the square root of 2, divide by the square root of 2, this cancels, and here I'm left with 7 over the square root of 2. But remember, you can't leave your answer like that. You'll have to rationalize that denominator. You guys are really good at this in class, but what you would have to do then is multiply by square root of 2 over square root of 2. And that's going to give us 7 square root of 2 over 2. Now normally we would go ahead and divide that, the 7 over 2. And if you did that and you made it a 3.5, I would accept that. But really we can just leave our answer just like this here, okay? And since that's your x value, notice that's going to be the same for this x and for this x. So our answers to A and B are this same answer, 7 square root of 2 over 2. So this would be answer to A and answer to B. Okay? Okay, let's take a look at number 2. In number 2, we're looking at a 30, 60, 90 triangle, which again is this pattern here. And I know it's a little bit hard to see, but this is x, 2x, and x square root of 3. So let's draw the one that this problem is talking about specifically. Got a 30, 60, 90, where the 30 is the smaller angle. So it tells me that F is at my 90-degree angle. E is my 60-degree angle. That would be this one over here, which would leave this one to be D. And it tells me that FE is 9. So this down here is 9. Okay? That actually works out really nice because this 9 is in the same position as my x. So I already know what x is. Now I just have to figure out what 2x and x square root of 3 are. So DE, that's your hypotenuse. That's the 2x. So to figure that out, I'm just going to do 2 times x, which we already know is 9. And so our answer there would be 18 for part A. For DF, this one here, notice I need to take the x and just put it next to a square root of 3. That's 9 square root of 3. So my answer for part B would be 9 square root of 3. Okay, so this one was much easier because you didn't really have to solve to figure out what x was first. Okay, 3 and 4, both are asking you for exact values. And as soon as you see exact values, I want you to be thinking unit circle. Okay? Remember, on your test, you do have a blank unit circle that you'll have to fill in, just like on your quiz, and then you would use this to find your answer. So, looking at my unit circle, at 60 degrees, the coordinates are 1/2, comma, square root of 3 over 2, and the cosine is always the first one. So cosine of 60 would be 1/2. For the second one here, the exact value of tangent of 30, that was one I showed you how to calculate that. At 30 degrees, the coordinates are reversed from that 60 degrees. So it's square root of 3 over 2, comma 1/2. And then we talked about how to divide it. So we would do 1/2 divided by square root of 3 over 2. But I told you for those that really the easiest thing to do with those would be just to memorize them. And tangent of 30 comes out to be square root of 3 over 3. Okay, we'll reiterate that in class tomorrow again. Okay. 5 and 6 are easy. Estimate to the nearest thousandth. That just means put this straight into your calculator. Okay. So off my calculator, tan of 73, and nearest thousandth is 3 decimal places, so I get 3.271. For number 6, cosine of 49 is 0.656. Okay, hopefully that's not too bad. Okay, so just to recap, here's all our answers 1 through 6. All right, we're going to move on to number 7. So number 7 says, in this triangle at the right, this ratio, so nm over ln, is the what of n? Well, it's asking about a ratio, and the ratios we learned were the trig ratios, like sine, cosine, and tangent. So if I were to look at this one, and it says I'm talking about angle n, that's right here, so that's my reference angle, okay? From that angle, side nm is it's right next to it, and it's one of the legs, so that would be the adjacent side. And then ln is here across from the 90, so that makes it the hypotenuse. So if I'm using adjacent and hypotenuse, and you're thinking about SOHCAHTOA, hopefully you can get that this is the cosine ratio. Okay. Number 8 is going to work very similarly. With this one, it's talking about angle T, so that's my reference angle. You're always starting from an angle. RS is directly across from that, so that would be the opposite side. And RT is across from the 90, which makes that the hypotenuse. So opposite and hypotenuse, if you're thinking SOHCAHTOA, that would be SO, which is the sine ratio. Okay. And number 9 is one that's going to ask you to draw your own picture. I know you love these. So a 12-foot ladder. This should be especially entertaining with me drawing on this little thing. Okay, because my artwork was so good already. A 12-foot ladder touches a building. So here's my ladder. Here's my building. This is 12 feet. And it says it makes a 70-degree angle with the ground. So when I see that, that's what tells me where to put my 70 degrees. It's where the ladder meets the ground. So this is 70. Okay. And I want to know how far up the building does the ladder reach. So I'm looking for this distance here. This is a right triangle, so I'm going to be using SOHCAHTOA, sine, cosine, or tangent. Okay. If I'm starting from this 70 degrees, the x here is directly across from that, so that's my opposite side. And the ladder is across from the 90, so this would be my hypotenuse. So that tells me that I'm using the sine ratio. So I'm going to set this up, and I really encourage you to write this out. Sine of 70 would equal opposite over hypotenuse, so that's x over 12. Okay, from my calculator, sine of 70 is 0.9397. Whoops. Then I'm going to put this over 1 and cross multiply. So really I'm just going to end up doing 0.9397 times the 12, because x times 1 is just x. So when I do that, let's see, I end up with 11.2764. This is a distance, so I think 11.3 would be acceptable because it doesn't tell you a specific thing to round to. 11.3 feet. And if we check, that does make sense with the problem, because if it's a 12-foot ladder and it's leaning, it's not going to make it quite 12 feet up, but probably pretty close. Okay. Let's move on.